Hi all. See this is a problem of vector algebra which you can already seen that it's appeared in JEE Main 2009 paper. Okay. So what it says, we are having four vectors A, B, C, D and they satisfy the given relations, right, that what is already given. Now here we have to first check that they are coplanar, that means they are lying in a plane, yes or no. That's the option 2. And based on that, if they are lying in a plane, then only we can check for that they are parallel, non-parallel and all that stuff, right? So we'll check that, okay, because the option C and D. So first let's assume few things, right? So obviously we are having 4 vectors and they are unit vectors, and also it says that they are having definitely at angle, right? So we'll assume that let the angle between the vectors A and B is theta 1, angles between C and D is theta 2, and the angle between the vector A cross B and the vector C cross D is alpha. Okay, so these are the important conditions, right? Now whenever the angle is known, obviously we are able to find what is A cross B, what is C cross D. So therefore we can find that mod of A cross B, it's equal to mod of A, mod of B, and sine of the angle between them, that is theta 1. As it is a unit vector, so therefore mod of A1, mod of A and mod of B is equal to 1, because the vectors are unit vectors, is already given. So therefore we can calculate the vector C cross D here similarly. So we'll find that C cross D is equal to mod of C, mod of D, sine theta 2, and that's it. So that gives me that sine theta 2, because here also CD are mod are 1. Okay, so this is 2. That's it. Also let's take the given condition. It says that A cross B vector multiplied by the another vector, that is CD, is equal to 1. Okay, so see that here says that A cross B dot C cross D is equal to 1. Okay, this is the dot product. Okay, now whenever we take about the dot product, so therefore we can apply the definition of dot product here. So definition of dot product says that mod of A cross B multiplied by mod of C cross D and cos of angle between them, that's alpha, that's equal to 1. We already calculate what is A cross B and mod. So therefore we'll find sine theta 1, sine theta 2, cos alpha, and that's equal to 1. That's it. So this is the given info, right? That sine theta 1, sine theta 2 and cos alpha. So what is theta 1, theta 2 and alpha? This is the angle between the vectors, okay? That's okay. And also we know that, right, that for whatever angle the theta 1, theta 2, alpha may be, the sine theta, sine and cos value is lies between -1 to +1. So therefore, right, as the products of everything, okay, it's equal to 1. So the only conditions that it not possible that everything is equal to 1. So therefore it's imply that sine theta 1 is definitely equal to sine theta 2, definitely equal to cos alpha, and that's equal to 1. That's imply that it's obvious that theta 1 and theta 2 are 90 degree and alpha is equal to 0. So what that means, that theta 1 and theta 2 are 90 degree. That means that the vector A is perpendicular to the vector B. Theta 2, that means that vector C is perpendicular to the vector D, and the vector A cross B is actually parallel to the vectors C cross D. Now, as these vectors are parallel, so we can assume that A cross B is equal to some constant lambda multiplied by C cross D. That's it. So these are the given relation. Now what's our aim? My aim is to prove that they are coplanar. What is the condition of coplanar? That the scalar product is 0. What is the scalar product? That means that A, B, C, the scalar product, right? So take the scalar product now. So therefore the scalar product we will consider A, B and C, the scalar product of the three vector. That can be easily written as A cross B dot C. Now see that if I take the dot product, we find that A cross B is equal to lambda into C cross D. So therefore it can be easily written as lambda into C cross D dot C. Now see that what is that statement? It says that it is obviously 0, that C cross D dot C is 0. If you don't have to understand, see that this one finger of me is obviously the vector C, another vector is D. So C cross D is the plane that is the perpendicular to both of them. And if I take a dot product, that means that we are taking the dot product of two perpendicular vectors C cross D and the vector C. So that's why that gives me 0. Okay, and so that's it. So next, if we try to calculate that the scalar product again in the similar way A, B, D. So therefore also you will find that that gives me that the vector A cross B, we have to take the dot product with D. That gives me lambda into C cross D. Taking dot product with D, that gives me 0. So therefore it's imply that the vector A, B, C lies on plane and the vector A, B, D also in a same plane. That means that option A and option B stating that they are coplanar, okay, that's actually wrong, right? So therefore in this case you can say that these two vectors are actually coplanar, they lies in the same plane. So therefore these two options are wrong, okay. So that's it. Now also see that from here we can conclude that the vector ABC and ABD are in a same plane. So at the final line let us conclude that, so therefore the vector A, B, C and D lies in a same plane. That's it. So that's the one important conclusion we draw from this problem. Now come back that see that one information is left, that is A dot C is equal to half. Let's take that info. So here it's also given that the vector A dot C is equal to half. That's imply that mod of A, mod of C and the angle between them. So let us consider that angle as alpha beta. So cos beta is equal to half. That's imply that cos beta is equal to half, and that's imply that beta is equal to 60 degree. So the angle between the vector A and C is 60 degree. So that's the conclusion we draw. Also we'll find that the angle between AB 90, CD 90 and all that, right? So as we know that, and also we know that these are lies in the same plane. So therefore we are able to draw that, right? So let's try to sketch that in this place, right? So suppose this is a plane, so we are able to draw a vector A. The vector B is always perpendicular to it, that's okay, and it says that angles vector C makes an angle 60 degree with the vector A. So therefore we draw a vector C which makes an angle 60 degree, and also the vector D is perpendicular to D, so that's D, right? So therefore we get this is 90. Now we know that the angle around a point is actually 360 degrees, so therefore the angle will be 150 degree. So this is the figure, right? Now here, to make our life simple, we just make everything passing through the same point, right? But that is not true for every time in vector, right? So we can spread it off, right? But on maintaining that these are actually follows, the angle remains same, right? So therefore we just spread it up, and this is maybe the position of the vectors A, B, C, D, okay? Now think on that. BD. No, it says that BD are non-parallel. Obviously, B and D are non-parallel because they are having an angle 90 degree, 150 degree. So therefore, it is obvious that BD will intersect at some point because they are having some angle between them. So therefore, obviously, we'll see that option C in this particular case is the right option. And if I check for option D, okay, maybe, so you see that AD are parallel. Obviously, AD are not parallel. Why? Because the angle between AD again became 150. So there is an angle. B and C are parallel? No, obviously B and C is not parallel. Again, the angle between them is 150. So as there are some angles, so obviously they are not parallel. Parallel means the angle must be 0, right? So, or maybe 2 pi or something like that. Okay, but angle is 0, right? So therefore, you will say that this option is obviously wrong. So that's why for this particular problem, we are having only one option, and that option is C. And that's it. Hope you understood the problem. Thank you.